Welcome back, everybody, to Dilemma's Concepts. What we're looking at today is how do we solve trig equations. So let us start off with this first question here. We want to solve where sine x is equal to a half, right? And where x is less than or equal to 360, but greater than or equal to 0. So all our solutions will be from 0 to 360. All right, so for this one, sine x is equal to a half. So what we want to do is we could jump to our special triangle very quickly here. And looking at our special triangle here, this is 60, 30, 1, 2, and the root of 3. So we're looking at how does this relate to sine, right? So the sine of 30, as we could see, sine of 30 is going to give us the opposite over the hypotenuse here. Because remember, from the trig ratios, sine of the angle is the opposite side over the hypotenuse side. So we're saying here that sine of 30 degrees is going to give us a half. So this is one solution, and this is an acute angle. So you could see here that the angle we're dealing with here is acute, right? The angle is an acute angle here. So where else again sine would be positive, right? Because this is positive a half. So let us quickly look on the 4 quadrants, right? So we have C, A, S, T. Talking from 0, 90, 180, 270, back to 360 here. We're going in an anti-clockwise direction. Now, sine is positive in the first and the second quadrant, right? So it simply means then that the related angle, the next angle for sine that will give positive a half will be in quadrant 2, right? So how do we find that angle in quadrant 2? So in quadrant 2, of which we'll call the second quadrant, you'll find the angle by simply taking 180 minus the acute angle. Why? Because we're talking about this is 30 here, and the related angle is going to be everything coming back to here. However, this is 30. So everything, as you could see, would be 150. So 180 minus 30 degrees would give us 150 degrees. So the second angle for sine that will be positive a half will be 150. Therefore, we can conclude that x is equal to 30 degrees and 150 degrees. What if we have the cos of, say, theta is equal to negative root 2 over 2, where theta is less than or equal to 360, but it's greater than or equal to 0. Again, we want to look at our special triangles, but we want to remember one thing, that 1 over root 2 is the same thing as root 2 over 2, right? So 1 over root 2, as you could see, is equal to root 2 over 2. So I'm going to focus on a triangle that has root 2 in it, and that is going to be my 45, 45 triangle. So knowing these triangles offhand is very good. So the 45, 45 triangle, 1, 1, the root of 2. So here it is, that the cos of 45 degrees will equal to 1 over root 2, which is the same thing as root 2 over 2, right? And how did we get that? I could quickly give an example. 1 over root 2, if it is rationalized by multiplying the numerator and the denominator by root 2, you would see that we'll end up with root 2 at the top, and root 2 times root 2 gives 2. So 1 over root 2 is equivalent to root 2 over 2. So then we're looking at that here, right? So 45 degrees is the angle that we're talking about, because adjacent hypotenuse, so it's 1 over root 2, which is root 2 over 2. One thing that we have to focus on is the fact that this is negative. So we want to look where cosine is positive, where it is negative. So we pull up this, right? C-A-S-T, right? All right. So if you want something to remember, we normally say all students take calculus, going around like that. All students take calculus. So we can use that to remember. All of them are positive in the first quadrant. Sine is positive in the second. Tangent is positive in the third. Cosine is positive in the fourth. So it simply means that for a negative cosine, I will be in the second quadrant and the third quadrant here. So I need to find the angles relating to my acute. What is my acute angle here? My acute angle is 45 degrees. This is my acute angle, which means then that I'm focusing on 45 degrees. So I'm focusing on these angles. So this is 45, which is my acute. This is 45 here. And this is 45 here. So it simply means then I'm going for the negative responses. So I'm going to go here. And then I'm going to go all the way to here, right? So let's look at the one in the second quadrant. So in the second quadrant, it's going to be 180 degrees subtract my acute, which is going to be 180 minus 45 degrees. And this is 135 degrees. That's my first answer for theta. The second answer, because it's negative, will be in the third quadrant. So that angle in the third quadrant is going to be 180 plus the theta. That's how we're going to get past 180. This is 180. We're adding this to it, right? So it's 180 plus 45, and I believe this would be 225 degrees. All right. So then I could conclude here, right? I could conclude here that theta is equal to 135 degrees, and it's also equal to 225 degrees. So those are my values for cosine, so that I will get negative root 2 over 2. All right, let's look on another problem. We're still going between 360 and 0. So theta is between that. One of the things that we have to bear in mind is that we cannot solve with two different trig functions. Here we have sine and here we have cos. We are not able to solve with two different things. So at some point in time, we have to find a single trig function. What we could do is to get them on either side. So I'm going to get the cos on that side. Mathematically, I'm going to subtract cos theta from both sides. So let me rewrite this. I'm looking at sine theta is now equal to negative cos theta. So the next thing I realize I can do here, I could divide both sides by cos theta. So I'm going to divide this side by cos theta, balance the equation by dividing this side by cos theta. Now, let's do some canceling. This will cancel itself, leaving negative 1. So sine theta over cos theta is negative 1. There is something that you'd love to recall at this time. We want to recall that sine theta over cos theta is the same thing as tan theta. So that is an identity that we have to remember, which means I could now substitute tan theta for all of this. So at this time, I am able to get one single function, which is tan theta equal to negative 1. And at this moment now, I need to check. I want to check, how do I get this negative 1? So I'm going to refer back to my special triangle. So I'm going to pull up the 45, 45, because that is a triangle with 1s on it. So with the 45, 45 here, 1, 1, the root of 2. I'm seeing that the tangent of 45 is opposite over adjacent. This is going to give me 1 over 1, which is 1. Now I'm going to use this to my advantage. The acute angle that is linking to 1 is theta is 45 degrees. Now remember, we have to focus on the real thing here. This is not positive 1, it's a negative 1. So I want to go to my quadrants, trying to remember where is tangent negative. So we're talking about quadrant 1, 2, 3, 4. In the second quadrant and in the fourth quadrant. So in those two quadrants, everything for tangent is negative. How do we get those responses? In the second quadrant, as you could see here, it's going to be 180 degrees minus my acute angle. That is going to be 180 minus 45, and I'm getting 135 degrees, which means a tangent of 135 will give me negative 1. In the fourth quadrant, how do I find my angle there? It's going to be 360 degrees, and I'm going to take out that 45 degrees, which is going to leave me with 315 degrees. Remember, though, that all the angles are attached to the x-axis. Those acute angles are attached to the x-axis. So this is 45, this is 45, this is 45, this is 45. We're suggesting here that what we were doing at first, where we're moving from 0 to here, second quadrant. And that is why we would have said 180 minus the 45. The second movement is that we're moving from 0, but all the way to here. And as you could see, it would be 360 less this angle here at 45. And that is why we employ this for that one. Conclusion here is that we can now conclude that theta is equal to 135 degrees and 315 degrees. Sine x plus 1, and this is equal to 0. Now, sometimes when I get this, already one good thing, I'm seeing one trig functions here. I'm seeing sine, right? But when I look at this, I'm realizing that there are a number of ways we could do this, right? A number of ways we could do this, but one of the easiest ways is to see this as a quadratic. Let us observe. We're talking about sine square x, and then we're talking about sine x, and then no sine, right? So what we're seeing here is something like this. If I should rewrite this and say, let sine x equal y such that 2y squared plus 3y plus 1 is equal to 0. So I could substitute sine x as y here and then rewrite this, and then I'm going to solve this regular quadratic equation for now. So I could factorize this. 2y, we have a y with a plus 1 plus 1, right? So we're looking at 2y plus 1, and a y plus 1 is equal to 0. So at this stage, what we want to do now is to say, all right, either 2y plus 1 is equal to 0, which means that 2y is equal to negative 1. Their y is equal to negative a half. That's one case. Or y plus 1 is equal to 0, which means that y is equal to negative 1. All right. So in looking at this right now, we're looking at where y is equal to negative a half and y is equal to negative 1. But remember that the original question had no y in it. So we're going to have to recall that this is what we did in an effort to solve the problem. So now we're going to substitute y, sine x where y is. So we have two responses to look at. So y is equal to negative a half. Therefore, we could say sine x is equal to negative a half. And where y is equal to negative 1, we could say sine x is equal to -1. So we're back now at the beginning where we could now find these solutions and we will be good. So let us take a look at finding these solutions. All right, so we want to find where sine is equal to negative. There are two places that sine is equal to negative. First, second, third, fourth. Sine is only negative in the third and the fourth quadrant. So what we're going to do is to pick up the values and then we're going to try to find them there. For example, let's look at this, right? So this one is kind of special, so we're going to look at that quickly. But for this one, I could pick this off my triangle here. I could pick this one off my 60-30 triangle. We could see that the sine of 30 will give me a half. So sine 30, which is opposite, so this is 30 here, opposite over the hypotenuse, 1/2. So sine of 30 would have given me 1/2. So this is the acute angle that I'm going to use to relate to the responses. But remember, at the end of the day, I need -1/2. So that is why I'm going to go into quadrants where it is negative. Now, so for this one, in the third quadrant, right? The third quadrant, we're focusing on getting the negative. It's going to be 180 degrees plus 30. And that is going to give us 210 degrees. So sine of 210 would give us that -1/2. All right. So we're talking about x is 210 degrees. That's one of our solutions. All right. So in the fourth quadrant, x is going to equal to 360 minus the acute angle, which is 360 minus 30 degrees. And we're looking at 330 degrees right there. So it means then that x is equal to 330 and 210. The sine of these angles would give us -1/2. And x is equal to -1. Remember that sine and cosine function between +1 to -1. So then we're going to have to go on that unit circle. One here, these spots. The coordinates for these are very important to understanding what's going on. So we have a 1, 0 here. We have a 0, 1 here. We have -1, 0 here. And we have 0 and -1 there. On the unit circle, the coordinates are as follows: cos, sine, x, y. So all the x values are cos, all the y values are sine. So we want to see where is -1 for sine anywhere. So let's look. That's 0, that's +1, this is 0, and here is a -1, right? So we're looking at this one spot here where sine is -1 in that whole 360. This is 90, this is 180, and this is 270. Back at 360 there. So at 270, so x is equal to 270 degrees. We're looking at where x is going to equal to 210 degrees and 330 degrees. Also, x is equal to 270 degrees. Here are the three responses.